Hello everybody, welcome back to the shop. Continuing to work on this water pump here. The other day I made a video making some leather piston seals for the piston inside here. And today I'm going to be pouring some new Babbitt on it. This particular pump is a double acting pump, and so here's the piston rod. Piston's inside here, and these guides guide this I don't know, whatever you want to call it. And there's originally Babbitt in here, and the Babbitt is the bearing for these two guide shafts. And it was fairly clapped out, so I'm going to pour some new Babbitt. I already started out by melting out the old Babbitt. You can see there's nothing in there. Also, you'll note that there's two grooves cast in there, as well as the you can see the oil hole in there from that. But anyway, those two grooves, most bases for Babbitt bearings will have some sort of irregularity in it to grab and hold the Babbitt. So in this case, since the motion is linear, there's two rings in there, two grooves that'll hold the Babbitt. So anyway, I have everything installed. Now, pouring Babbitt is like a lot of things where it's 90% preparation and the other 10%, if that, is actually pouring the Babbitt. So we want to make sure everything is aligned and level and straight and whatever else. And that's pretty easy on this pump because this piece, I don't know, I still don't know what to call it, is bolted or screwed on with a nut onto this pump shaft, and the nut goes up here, and that's it. So that aligns everything. So I already put this plate back on, put the packing gland in with packing, so that aligned the shaft every which way. So just by tightening this nut down, it should straighten everything out, and then we'll be ready to pour the Babbitt after a few other preparations, one of which is smoking the parts that you don't want the Babbitt to stick to. In this case, it's these shafts. You don't want the Babbitt to stick to these, but you do want it to stick to this. So we'll take our oxyacetylene torch, turn it on just pure acetylene, and run the flame over the shaft, and that'll put a heavy deposit of soot on there, and that soot won't really contaminate the Babbitt, it won't really do anything, but it will ensure the Babbitt does not stick to this metal. As for this, I just wire brushed it out. We don't really need to do anything to ensure the Babbitt does stick here because we have these grooves. Some people will tin the surface, the cast iron or whatever surface that the Babbitt's going to stick to. And the few things of Babbitt that I've poured, I've never done that. I don't think I would have really good luck even if I did try, because most everything, all this old stuff, has been soaked in oil and grease for the past 50 or 100 years, and all castings are porous, so the oil and grease is going to soak in there, and as you heat it to try to tin it, that oil and grease is going to bubble out, and the tinning, the lead, the Babbitt, whatever, is not going to stick. So I just clean it, and that's that. That's good enough. So the last thing, once we smoke it, put this on, align it the way we want. The last thing to do is to preheat. Preheating won't be a super big job for this because this is fairly small. If you're pouring an engine bearing, a hit and miss or oil filled engine bearing, preheat's going to be a lot more important because you have a real large heat sink of that cast iron that's going to soak up the heat from the Babbitt and make the Babbitt freeze before it's supposed to. That's still important here, but we're going to be, it's just the way we're going to pour the Babbitt in. It's going to be a lot straighter of a shot, and it's just not as much of a concern. But we're still going to preheat. It'll be a lot easier to preheat because everything is so small. Oh, and the last thing, last thing is damming. I have some damming compound here. I bought this from Roto Metals, which is where I buy my Babbitt. This is just some sort of a clay with a fiberglass reinforcement in it. You can see how it's kind of fuzzy and fibrous. The old school stuff had asbestos fiber in it, and of course, you know, they don't make that anymore. If you find some, good for you, hold on to it. You can reuse this stuff over and over. People have used a lot of other things, modeling clay, a mixture of flour and water, or cornmeal, flour and water, clay, I think I already said that. And if you have larger gaps that you need to dam, you use something solid like a piece of leather or a piece of wood, or maybe even, I haven't used this, but maybe cardboard, solid cardboard, not corrugated. Because Babbitt, when it's molten, is only about 400 or 500 degrees or something like that. So it really won't set stuff on fire, it'll char it, but that's it. So if you have a big gap, you would use something like that, wood or leather, and then the very small gaps between the leather and whatever else you're damming against, then you'd use clay as more like a gasket or a sealant. But for this, again, the gap is pretty small. I'm just going to use this. Now as I'm talking, one more thing to consider. I know this is a lot of talking, but like I said, 90% preparation, so this is going to be 90% talking. So I have a lot of information to tell you. One last thing to consider is the height of your casting. In this case, it's only about, I don't know, 2 inches or so. It's not a big consideration. If you're pouring, I don't know, if that guide was taller, or if you're pouring a big bearing, engine bearing or something, where the height from just elevation, doesn't matter the width or the depth, just the height. If the height is very tall, from the very bottom piece of Babbitt to the very top of the vent hole or funnel where you're pouring the Babbitt in, if that height is tall, you have to make sure that your damming on the bottom is very, very strong and has some good structural integrity to it. Because just like any liquid, there's pressure associated with that. You go under a swimming pool, the deeper you go under the swimming pool, the more pressure there is on you, and you might get a pop in your ear and you'll have water in your ear for a little while because there's more pressure. And that won't happen if you're closer to the surface. The same thing is consideration with Babbitt, especially because it's such a heavy, dense metal. It's mostly lead, or some Babbitts are tin, mostly tin, but either way it's a dense metal. So it doesn't take much depth or much height of your casting for a fair amount of pressure to be on the bottom. So that pressure is going to be acting everywhere, and it's going to be acting on your damming, on your seal or your gasket or whatever. And if you don't dam well enough, especially on the bottom of your bearing, as you pour, the pressure from the Babbitt is going to push that seal out, push that damming out, and your Babbitt's going to spill everywhere. Best case scenario, you'll just screw it up and you'll have to redo everything. Worst case, that Babbitt, molten Babbitt's going to, you know, spill its way down your boot or something and cause a bad burn. On that note, speaking of burns and safety, you know, of course, gloves, welding gloves, long sleeves and all that stuff. Not just safety glasses, but glasses and a face shield. Face shields are great, but a lot of stuff can get around a face shield, so I like to use both. And moisture is a big consideration. Not a real big problem if you're melting down an ingot like this, but if you have a bunch of Babbitt scraps that you're melting down, it's possible that there's some moisture in there. It's also possible there's moisture in what you're pouring into, which is another reason why it's important to preheat. It drives the moisture out. But if there's moisture in the Babbitt that you're melting, if some of it gets molten and then that water decides to flash into steam, I don't know how many times, maybe somebody can comment down below, but steam is, you know, one droplet of water, which is tiny, can expand to many times its volume once it goes to steam. And if that happens at the bottom of your ladle, your melting ladle, that can blow Babbitt everywhere and be very dangerous and painful and harmful. So that's another thing to consider and be aware of and take the proper precautions against. Now this Babbitt is a reused Babbitt. I think it's stuff that I melted out of my Patton Brothers a couple years ago when I did those bearings. And this is the Babbitt out of this pump. It's always important to have extra Babbitt. If you have extra, you just let it cool in the ladle, or you can pour it. I use a cupcake tin, and I just pour it into the cupcake tin if there's extra. If you don't have enough in your ladle when you pour, well, you're screwed. You got to pour it again. But if you have too much, it's not a big deal. And you can always reuse Babbitt as long as it's not too contaminated or anything. You can see this has some junk in it from when I melted it out. There was some paint and stuff in there, but you melt this in your ladle and you just gently scrape it and stir it, and you can get all this contamination out. When you're melting the Babbitt in the ladle, the way to, well, at least the old school way, you can use a thermometer, of course, or a thermocouple, but use a pine stick. Just if you have a paint stirring stick or something, use that to stir it. It works great. It won't just flash into flame like you might think. Again, this is only about 500 degrees when it's molten. And when that pine stick just starts to char and turn kind of a maple syrup color, molasses color, something like that, that's the right temperature. And then as you're stirring it, you can kind of go from the bottom up. And when this is molten, the different alloying elements in here, some are denser than others, so some will sink to the bottom and float to the top. So you want a top to bottom to top scooping motion to stir. And that'll also bring up any contamination and slag up to the top of your ladle. And you can scrape out, scoop out the contamination, because that'll float on the top. A piece of sheet metal, stainless steel, or an old spoon or something works good for that, just because you have a little better scooping action. It's a little less clumsy than a piece of wood. So I'm going to start by smoking this. Yeah, that's it. I'm done talking now, for now anyway. I'm going to start by smoking this. Put this crosshead, I guess you call it a crosshead, on there, and we'll dam it up. Alright, so we're pretty much ready to pour. We've got this smoked, everything installed, the damming squished in there. You know, I didn't film myself doing that, but if you don't know how to mush clay around, you go back to third grade art class, you can figure it out. Also make sure to plug up those oil holes, and depending on the situation, you might actually want to pour your bearing through the oil hole, but in this case I'm just going to be pouring right through the top. Another consideration, again, these are things I'm just thinking about as I'm talking about them. Depending on your bearing, you might want or need an excess of Babbitt, molten Babbitt, above your bearing, because as the Babbitt cools, just like anything, it's going to shrink. So in this case, I'm going to pour in through the top. It'd be helpful if you saw where I was pointing. I'm going to pour in through the top and just pour it right up to the top. But if let's say this was a rod bearing, I'm pouring in through the oil hole. As that Babbitt cools and shrinks, it's going to suck in through that oil hole, and you're going to have a void right there. So what you'd want to do is use some damming and make a little well, like a funnel and well, to help funnel in the Babbitt as you're pouring it, and also have a reservoir of molten Babbitt above the bearing, so as it shrinks and pulls molten Babbitt in, it'll pull Babbitt in rather than pull in air and make a void or a pocket. But with this, it doesn't really matter. It'll suck in a little bit, but it doesn't matter whatsoever if the Babbitt is right to the edge or down a little bit. I'm going to preheat this with a torch, and you can just use the back of your hand or just kind of gauge how hot it is. It's not the most critical thing in the world, but you can buy these. These are temple sticks. You can get a variety of different temperatures, and what it is, it's kind of like a crayon, but when the thing you're heating up is at the temperature of the stick, which this one is 375, it'll melt. Now I got a couple different ladles here. This is just a standard new one that I bought from McMaster. It was only like 25 or 30 bucks, and I made a nice sliding wood handle so I can hold it. but also I can slide it away so it doesn't get burned by my heater. I'm just going to use a torch to melt this Babbitt because it's not a lot of Babbitt, but for a bigger Babbitt bearing, I would use my propane forge with a little ring to hold it up and melt it that way. Another nice ladle that we have. I've never used this one, but this is a bottom pour ladle. You see there's there's the spout, and it goes into the bottom, and there's some holes in there. And so as you pour, the Babbitt pours out the bottom rather than the top. So if there's any dross or slag on the top, it's not going to pour into the bearing. So it keeps your bearing a little bit cleaner. So let's get this heated up and preheated, and we'll melt our Babbitt and be ready to go.
Who else has lupus?
It's really not
So
that.
they go ahead.
Yeah, but she cries out like it's a fucking debilitating. It's not.
Well, I knew there was a radio.
Ah, motherfucker. Alright, so I redid the damming. I used some crumpled up aluminum foil, and then I put the clay over that, and then I topped that off with more aluminum foil. I held it in with some wire. That's okay. See, this side was a little colder, so you see it froze before it leveled over there. I heated this one more than this side. I was going to do this side and then heat this, but I decided just fuck it, just go for it. So looks like that worked out. We got a little extra Babbitt, which is always how we want it. More is better than less. So we'll set this aside, let it cool down, and I can knock it out and reuse it later.
So you can keep reusing that, huh?
Yeah, as long as you don't overheat it, because if you overheat it, you might burn out some of the elements. But you just keep it a good heat, and as long as you keep spooning the slag out of it, you can keep reusing it. Some of this Babbitt is what came out of there.
Now that one that froze, you said, do you have to trim that flat on top?
On the back side here, it bubbled out.
Yeah.
Not really bubbled, but yeah, I'll scrape that flat just for cosmetics, and it's not going to interfere with anything. Nothing else goes on top here, but just to make it look nice, I'll scrape that. And then again, you can save those scrapings and melt it into a block.
How many times can you reuse it?
Indefinitely.
Really?
Yep.
It doesn't hurt at all? Do you have to mix some new stuff in with the old stuff?
Nope. Long as you treat it well. But
will contaminants like oil that's been on it for years hurt it, or does that come out when you...
It burns out, and yeah, so like I was saying before, if you heat it, or when you heat it and melt it, all the slag and stuff. Man, this is weird talking to a camera for once instead of talking behind it. But yeah, when you heat it, all the slag and stuff burns up, comes to the top, and you just scoop it out with a little stainless thing or the wood. This worked okay. I was just kind of flicking the stuff out of the ladle. But anyway, that's that. So we'll let this cool down. Don't fuck with it for a while. It's hot anyway. And then we'll take this apart. And it's going to be a little bit of a fight getting it off, because that messed up one that I poured, that was even took a little bit of hammering. But we'll get this off and scrape the insides for a little bit of clearance, and it'll be ready to go. Well, I finally got it apart to do the final finishing. It was a little more of a challenge than I thought. See, I had to take these guide rods out of the holes they were in, even though I smoked everything, and I was also kind of assuming since the Babbitt would shrink, it would pull away from these rods, but it is possible that as it shrank around the rod, which I think is actually what happened. So it was pretty tough to get it out. You know, like I said, I had undid them from the pump, used a little bit of oil and just hammered them through, and they obviously came out. Unfortunately, without a little casualty, there's this little peg here. I was initially hammering on these pegs and this broke off. Luckily, I'm going to be running this pump a little bit differently, so I'm not going to be using these pegs at all. So I'm actually going to be taking this other peg off for cosmetic purposes. This pump is going to be going on my Bessemer Model FC, so eventually I'll be making a bracket for it and some other linkage to make it work on that. So anyway, so be careful. You know, cast iron, it's a bitch to repair, especially in a situation like this. I couldn't really even put a threaded stud in there because they're really using a lot of meat on this piece to put a threaded stud in. So, you know, as always, be careful with that. I wasn't thinking. So, started cleaning it up, and I started off chiseling off the excess here. I was just using a plain old wood chisel. It chisels the Babbitt off quite nicely. And then also, you could even just use a pocket knife or something. But I have these Babbitt scrapers. If you see these at a flea market and you're into this stuff, pick them up. This is used for scraping Babbitt. So I can get in there and just scrape away until this rod fits nicely. Even though this is an official tool, I might actually use a knife. I can get in there a little bit easier. And this long shank just makes it just harder on your wrist as you're pushing. If the cutting edge was closer to your hand, it's just easier to use. So anyway, so I'm just going to clean it up. You know, finish up the bores here. They do feel very nice. There's no porosity or anything. And just to show you, here's the other side with the aluminum foil that I used for damming. It kind of melted and formed into the Babbitt, so I'll rip that out the best I can. It's not a big deal, but this worked a lot better along with the clay. Like I said, I didn't follow my own advice. You know, I put the damming on. I thought this would be thin enough and also shallow enough that it wouldn't really be an issue, but it was. Also, when you're preheating everything, that clay softens up, or at least the stuff I was using, it softens up, and it doesn't hold as well as you'd think it would when you're forming it cold around whatever you're damming. So anyway, that's it. That's how to pour Babbitt. Once again, slightly different situation. And that's it. So thanks for watching. Hope you learned something from this and you can apply it to whatever you're working on that has Babbitt bearings. Make sure to hit the subscribe button. I think it's over there somewhere, and hit the like button. That's also over there. And also straight down below in the description, there's a link for a Patreon account and a PayPal email, or an email you can donate through PayPal if you enjoy living vicariously through these videos. I found that some people really just like watching these videos for enjoyment, not even to learn something, or maybe you learn something along the way. But at any rate, if you feel like donating and helping keep engines in the garage, go for it. I greatly appreciate it. And if not, just keep on watching. I appreciate it. And until next time, come on back for more.